Look at example number 4. We have a mobile that is formed using light rods, or essentially massless, and some light strings as well. And we have 3 fish labeled baby, mama, and papa. We're asked to determine the mass of mama and papa fish. And we know that the mass of the baby fish is 2 kilograms. So, the first thing I would do is draw a free body diagram. So we'll start off with this beam right here, this light beam here, where baby and mama are attached here. So we have the force of gravity of baby fish, and then we have the force of gravity of mama fish. And then we have an upward force of tension pulling upwards here. To find the weight of mama fish, we're going to find the torques about this pivot point. I'm just going to label that as point P. So we're going to do sum of the torques about point P equals 0. And so we have the weight of the baby fish. We'll just write mass of the baby fish times G times this distance. I'll just call that R sub B. And that's going to produce a torque that is going to be counterclockwise, so call that a positive torque. And then we have the weight of the mama fish, that's mass of the mama fish times G, then multiplied by this distance of 5 centimeters, we'll call that R sub M, and these should balance out to be 0. But this torque is going to be clockwise, so this torque is not going to be positive, it's going to be negative. So essentially these are balanced torques. Now G cancels out in both terms because that's constant. And so we have the mass of baby fish, which is 2 kilograms, times R sub B, which is 15 centimeters. I'm going to just leave that in centimeters because there'll be centimeters on both sides, equals the mass of mama fish times the distance from the pivot point to this tension here is 5 centimeters. So we'll put 5 centimeters here. So mama fish will be 2 kilograms times 3, which is 6 kilograms. So we're going to find now this force over here, so eventually we could do a static equilibrium of this beam. So this is, we'll just call that T1, I guess. Now, by using the force condition, the sum of the forces vertically should add up to 0. So the tension upwards that's supporting these 2 fish, baby and mama, should be equal to the tension up. So tension up minus the weight of the baby fish minus the weight of the mama fish equals 0. So the tension 1 will be equal to those 2 weights. So mass of the baby fish times G and mass of the mama fish times G. And then substituting, we'll get a tension of 78.4 newtons. Okay, so now to figure out the missing mass of papa fish. So I'm going to draw this beam over here now. And we know at the very end we have a tension of T1, which you just determined of 78.4. We have an upward tension right here. This is this from this string. And then we have the weight of papa fish over here, which is down over here like that somewhere. So this is T1, we'll call that T2, and there's the weight of papa fish. And then we're going to pick a rotation point about here, we'll call that point Q. And now we're going to use the sum of the torques about point Q equals 0. And so we have a torque produced by papa fish, which is going to produce a counterclockwise rotation, which is positive. So that's the force of gravity of papa fish, which you could just rewrite as the mass times G, multiplied by R sub P, which is going to be this distance here, which is 30 centimeters. And that's going to be balanced out by the other torque right over here from tension 1. So tension 1 times this distance, we'll call that R sub T or something. And that is 20 centimeters. So substituting in, we have G is 9.8, R sub P is 30 centimeters. Tension we got was 78.4, and then this distance is 20 centimeters. And this gives you the unknown mass of papa fish to be 5.33 kilograms. And there you go. We're done.